Very good evening. Am I audible to all? Good evening. Speaker Aditya. Yes. Hope no issue with the audio and video. In last session, we have seen the basics of theory of computation to understand what is a set. A set is a collection of objects where each object is distinct. And then we have seen how to represent a set when you have many elements or infinite elements. You can use a set builder to understand what is your form of the object and what are the conditions you should apply on that object, right? You're going to collect every object which satisfies the conditions. We have seen what is a set. Then we have looked at what is a symbol, string, alphabet, language. The symbol is nothing but a collection of symbol is anything in the world which is the smallest unit or block in the world and which we assume as one length. That's called a symbol. An alphabet is a collection of symbols where alphabet is nothing but a set which is a finite set which contain just symbols, right? Every symbol that is a one length, whatever you write is just called as a one length. Okay, you can call set of all one length strings. Alphabet is also called as set of all one length strings. Alphabet is also a special language in the world, but that language has all the strings of one length. Okay, you can call alphabet is a language, remember that point. And what is a language? Before that, what is a string? String is nothing but a sequence of symbols. That sequence has to be finite sequence, and you can have 0 or more symbols in a sequence to form a string. Okay, so strings also we have looked at various number of strings we have formed. There are infinite number of strings you can form for the given sigma alphabet. Language is again two types, but string is only one type, which is finite type, but language is two types, finite language and infinite language. Okay, finite language nothing but finite number of strings, infinite language nothing but infinite number of strings. Correct? So now after learning the basics, we have seen in the first class itself Chomsky hierarchy, like we have the mainly four types of classes, right? Type 3 to type naught, type 0. And type 3 class contains regular languages, and type 2 class contains all the context free languages. Type 1 contains all the context sensitive languages. Type 0 contains all the recursively enumerable languages. And type 0 class is the largest class among these four. And to understand each class or to understand the languages in each class, we have a different model to represent or compute. To understand regular languages, we have finite automata. To understand the context-free languages, we have a PDA. To understand context-sensitive languages, we have linear bound automata. Right? To understand recursively enumerable languages, we have Turing machine. This is what all about theory of computation. Now, the first topic which is starting now is regular languages. And in regular languages, there is one small subtopic which is regular expressions, and it has nearly 3 marks minimum weightage every year. So those people who study regular expressions, they can easily secure 3 to 4 marks in GATE exam, right? Any competitive exam, this topic has a more weightage to secure. And if anybody not joined in Telegram group, and please do that. And this is my Telegram group, and many people are asking, sir, where do you find the lecture notes or any practice material? So you can join this group every day. Just after the class, I'll share the file which is taken here, and this class notes will be shared, and any other material that I'm going to share in the same group. And in case if you are not aware, please access to this Telegram group. And if you are looking at the group, then definitely you can find here. This is my Telegram group. You can see this is a Telegram group. Like somebody is asking, are resources shared in this group? Yes, it is shared here itself. Okay. So in case if you are not able to find here, you can go to the file section here. In this files, you can find recent the one TOC introduction and TOC basics. 2 classes are covered. You can see as per the dates also, you can access them. Apart from that, you can find compiler material and many other materials you can find here. C programming and previous class notes, topic wise questions. There are a lot of things you can find in my file section, right? So this is what you have in the Telegram group. We ready to start the session? This session is all about the first topic, regular languages. In that regular languages, this is the one of the type of languages in our Chomsky hierarchy, right? Regular languages are there in the type 3 class. Every regular language, the studying every regular language that you are going to study is belongs to type 3 class, because type 3 class has infinite number of regular languages. Okay, here what is the type 3 class? Type 3 class is same as the set of, this is nothing but set of all regular languages. It's a set of all regulars. Okay, every regular is present in this class. And how many regular languages are there? There are infinite number of regular languages are there. How many regular languages are there? Infinite number of regulars present in the world over any sigma. So learning regulars itself, it takes years, but we study some of the regulars which can cover a lot of varieties of regular languages. And to understand the regular languages, we are going to start with regular expression. Regular expressions. We'll learn a lot of regular expressions. And then we will learn finite automata in the regular languages to understand it. Then we will understand regular grammar. These are the 3 different models, or these 3 different representations will help us to compute regular languages, right? And remember this, if you want to compute regular language, or if you want to solve the regular problem, you can use regular expression. So that's why we need to learn regular expression. Or you can use the finite automata, either DFA or NFA, or you can use regular grammar, writing RG. All these 4 representations are equivalent, and if you want to compute regular language, you can use any one of these 3 models because all are present. If it is non-regular language, if it is not a regular, you will not find all these 3. So for every regular you will find these 3. For every non-regular which is not here, then definitely you can't find them. Okay, so we are going to start with the first topic, which is regular expressions. And if anybody asks, why are you studying regular expressions? Because you want to solve, you want to compute, you want to represent the regular languages. Okay. Good evening. So you can use the Telegram group to ask the doubts. In case if it is any delay in the YT, because I can see it's not refreshing. Okay. We're ready to start the first topic, regular. Let me talk about for some time, because people um, might be worried, what are these regular languages? Correct? They have the very special place in this world. This basically these regular problems you can call regular languages, right? Why they have kept the name regular languages? Like, why not context free languages? Right? We know every regular language is a context free, but context free need not be regular language. Context free languages, they can take the help of this stack to solve it, but regular languages cannot take the help of any data structure in the world, because they are possible to solve using just states, right? So they do not require any memory to solve them. Every regular language or regular problem, every regular language can be computed without data structure, computed without additional memory. So you will represent using finite automata or regular expression or regular grammar. That would be enough to understand your input. You don't need to maintain any extra data structure to solve it. You have some control, and that control would be sufficient to solve it. Okay. And remember few points, if anybody want to relate. Every regular language, is context free language, is context sensitive language, is recursively enumerable language, because this language is present in all the classes. That is the reason you can call it as a regular language. We are only talking about one regular language. Regular language, I said, belongs to type 3 class, correct? And it's not just type 3 class, it is also belongs to type 2 class, also belongs to type 1 class, because this language is there in all the boxes, all the classes. That's why we can call it as context free because it is there in type 2, it is context sensitive because it is there in type 1, it is REL, recursively enumerable language, because it is there in type 0 class. Okay, so we are learning the very simple problem or language in this world which can be solved without any additional data structure, correct? So if you go for the second chapter, context free languages, you can take the help of stack to solve it. But without the stack also, some of the problems can be solved which are regulars. But these problems also can be solved with the help of stack, because they don't need a memory. You can use the memory. If you use the memory, obviously you can solve them. Okay. The first topic here is a regular expression, which is one of the model to understand the regular languages. Right. We'll continue this few days, like 2 or 3 days, to get confidence. We'll solve a lot of problems in the regular expression, and this will continue till the end of the first chapter. So every regular language we will try to represent expression, even in the next topic like finite automata also. See, the word expression requires both operators and operands. So mainly whenever you use expression, it purely depends on operators along with operands, correct? So it uses the 4 operators. It uses how many operators? 4 or 3, depends on how you treat them. So mostly I follow 4 operators, but textbooks also follow 3 operators, because 2 operators which are related or similar in that. So it uses 4 operators to represent or to compute, to describe, to represent, you can say, to describe or to generate, something like that, to generate or to compute. Which language? To represent a regular language or regular set. if you want to represent a regular language, you need 4 operators here. Okay, the regular expression is used to represent regular languages basically. Okay, so for every regular language, you can always find a regular expression. For every regular language in the world, for every regular language, what you can find? For every regular language, equivalent regular expression exists to represent. Equivalent regular expression always exists, no matter which language you take, regular. And not just one regular expression, you can write infinite regular expressions for every regular language. And also remember that for every regular language, you can write infinite equivalent regular expression, not just one. That's why this is a very important topic for the exam. You learn, still there is a lot to learn. Even you learn this topic, still there is a lot to learn about regular expression, because you cannot say all the infinite regular expressions. You can understand when they give in the exam. Okay. For every regular language, there are infinite equivalent regular expressions. There are infinite number of regular expressions present. To keep this in mind, even you learn regular expressions for any regular language, there are many other equivalent answers. That's why in MSQ, this kind of questions can come easily, because for the same problem, you can have multiple answers. Everybody understood the point? So what are those 4 operators that we are going to learn? Any idea? And any doubt that you have, you can scan this QR code and ask the doubts through Telegram also. What are those 4 operators that you require to learn in this topic? I said 4 operators, right? What are those 4 operators will help you to form a regular expression? The first one is OR, and second one is concatenation, and the third one is Kleene star. People may call it as Kleene closure also, or simply star. And this one looks like OR operator symbol, but it's a Kleene plus, or you can call positive closure. The symbol that you will use here is a plus. Which symbol you will use to denote? Plus. Here symbol is not required. The symbol can be omitted, ignored, the dot. When you are writing the concatenation operator, you can also ignore it, because if you don't write an operator at any place between 2 operands, you can assume there is a dot only. And it's optional. Kleene star, you will use the symbol as a star. And Kleene plus also same as plus. Then how do you differentiate both? By using number of operands. This operator is a binary operator, so you need 2 operands. Which operator it is? Binary operator. Whereas the concatenation is also binary operator, so you need 2 operands. Binary operator. And this one is unary operator, so just you require 1 operand to represent. This is also unary operator. That's why these 2 symbols are differentiated based on the operators, operands. This is a unary operator. That means you require only 1 operand. Anybody want to represent these expressions using these operators? We will write R1 plus R2, something like this. And here you can write R1 dot R2, or without a dot is also fine, like R1, R2. People know that it is just concatenation, because you have a no symbol written between these 2 operands. And here the R star, and here R plus. You write as a superscript. Okay, carefully write it. Now you can easily understand what is each operator. Everybody got this point? While studying, you can ask any doubt. You can access Telegram and you can post your doubt during your learning. Okay, and you may utilize this opportunity throughout your learning, because in my class the purely the content, and you will save a lot of time, because I do not teach the single concept for hours, because I know how much time to be dealt to understand a single concept in less time. In case if you do not understand, take more examples to practice. How do you speak this line? As a first time learner, you just speak like R1 or R2, or you may say either R1 or R2, or simply R1 or R2 you can speak, because plus means R here. Here R1 followed by, but you speak R1 dot R2, that's okay, R1 R2, that's okay, but actual meaning is R1 followed by R2, means after R1 R2 appears here, and this means 0 or more occurrences or repetitions of R, 0 or more times of R. Here the 1 or more repetitions or occurrences of R. We are going to have this repetitions of R here 0 or more times, here 1 or more times. We'll see what do you mean by it. What do you mean by either R1 or R2? If you want to understand, take an example, it will become so easy for you. Okay, when you write an expression, like I'm writing here expression, the expression if you write A plus B, and what is equivalent language that you get? You will get A comma B. It means you are talking about two strings. You can generate A or you can generate a B. So this A plus B will give you only two strings. It can't give you double A, it can't give you AB, it can't give you BA, but it will give you either A or B. Okay? It's simply like union. So here not only just plus, you can also use other operators like union, or all this can represent the same meaning. Okay, so this just like a mathematical union operator, no difference between union and plus. Some textbooks even they use union in place of plus. Like instead of writing A plus B, they can also write A union B without using even brackets also. And here, if you take regular expression, something like A dot B, then equivalent language, that's a set, correct? That's a language set, both are same. You will get only one string that is called as AB. You will not get any other string here. Even you can't generate 1A, you can't generate 1B, you can only generate AB. There is no other string. Okay, here if you take expression A star, and this A star can generate one language which has A power 0, A power 1, A power 2 and so on, which is same as A power n such that n greater than or equal to 0. And A power 0 here it represent epsilon. Anything power 0 in our TOC, we assume it as epsilon, because 0 symbols of any expression will be epsilon. Remember this point, epsilon 1A, A power 2 you can write as A followed by A. So this repetition times, it's A power 2 means A you write 2 times, which is double A. A power 3 means you write A dot A dot A. Okay, if anybody says 2 power 3, say 2 2 2, don't say 8. Okay, in DOC if 2 is your symbol, 2 power 3 means 2 2 2. You need to repeat 3 times. Fine. And this one is small difference between Clini star and Clini plus. A star means 0 or more times, like A power n where n greater than or equal 0. Here if you say A plus, then you will get a language which is A power 1, A power 2, A power 3 and so on. That means you will start with the power 1, which will give you same as a power n such that n greater than or equal to 1. I hope you understood all the 4 notations or 4 operators without any doubt. R is an operand. R here assumed as like the topic is regular expression, right? Whenever you want to refer regular expression, you write simply R. R represent an expression. It is operand which might be simple or which might be another expression, sub expression, you know, right? In mathematics, when you say x plus y, what is x? X is an operand which could be another expression if you want it, a minus b, something like this. You don't know, right? It's just an operand which could be another sub expression. Okay. Here R represent a regular expression. So R1 plus R2 means any expression plus any other expression or same expression, doesn't matter. Some expression followed by some expression, and some expression whole star and some expression whole plus. And what is R? R is operand. R is, understood, Aditya? Now, first, how do you write a regular expression? You can use the 4 operators or no need to use sometimes, because regular expression can use 4 operators. Without using also you can write the expression. Look at this, regular expressions, how can you represent? You can see that regular expressions. Okay, now I'm just talking about which are regular expressions. Look at this. Epsilon A. Assume that sigma is equal to a comma b. I'm using this notation. All these notations I'm using for sigma is equal to a comma b. A b and double A I B A. First, my question is, are these regular expressions? I don't have any operator here. Looks like, right? I don't have any operator, but do we call them as regular expressions? Yes, they are very trivial regular expressions, basic, right? You can use them as regular expression or you can use them as one of the operand in the regular expression. Okay, if you ask me here, do you have any operator? Yes, you can assume that a dot a if you want it. But if you look at this epsilon, there is no operator. A, no operator, correct? All of them are actually regular expressions. What are they? All are regular expression. So what do they represent? If you want to know language, what is the corresponding language? This is going to represent a language which is having epsilon, and this is going to represent a language which is having only a, and this is going to represent a language which is having only b, and this is going to represent a language which is having only double a, and this pi is called as the empty expression because it is going to generate nothing, but remaining all are non-empty expressions. This epsilon is also non-empty expression, even though it is empty string, but it is non-empty expression which generates something. Okay, and BA is going to generate the one string BA, and this is only this is only empty expression. Remaining all are non-empty expressions. Okay, is that clear? Now I have not used any operators till they are regular expressions, and these things you can use anywhere as operands whenever you like it. You know, example, can I write a plus epsilon? Can I write a dot epsilon? Correct? Can I write something like a plus b whole star? Can I write no, I plus epsilon plus ba whole plus dot a? Anything you can write. Now if you try to understand, all are regular expressions, but what do they generate? It may take time. Are you getting? I'm not explaining now what do they do basically, but are they regular expressions? Are they regular expressions? Now you may ask, sir, why are you explaining regular expressions? I'm pretty much aware of them. Yes, you are pretty much aware, but okay. Okay, before explaining some of the things which are not regular expressions and somebody has a doubt, Let me explain. In the beginning also somebody asked it out, pi and epsilon. Correct? I explained initially, even I'll write few things now. In the last class also I explained them. Pi, epsilon, A and AB. Okay? I'm just talking about sigma is equal to A comma B. What are they called as? Okay? Now, is this a symbol? No. These are only two symbols, right? Now, I can call it as a symbol because it is there in the sigma. It is also a symbol, correct? But can you call these two are symbols? Never. Because epsilon is the empty string, there is no symbol in it. And pi is, we don't call symbol. Of course, symbol in somewhere in mathematics, someplace. But in this sigma, the symbol means only A and only B. Okay, here only A is a symbol and only B is a symbol. Now let's talk about a string. Now when I talk about a string, this AB, I can call it as a string, no doubt, of 2 length, correct? We can talk about a string which is 2 length. And this is also a string which is 1 length. That's 1 length definition only called as a symbol, right? String which is 1 length. And epsilon is also a string of 0 length, correct? But we can't call pi as a string. Pi is never be a string. You can use in two places, either in sets or in expressions. Both are two different topics in the world. Remember that? Now you got a symbol, you got a string. Now I'm talking about expression. Now how many of you know all are called as expressions? This is empty expression. Empty regular expression. And this one non-empty. Empty string it is, correct? The name is empty string, but this is non-empty expression. Non-empty expression. Why? It generates one string, not a 0 strings. It generates one string, but this generates no string. That's what we call empty regular expression. And this one is also non-empty expression, right? And this also non-empty expression. And all of them are actually regular expressions because you can treat them as regular expression. When you ask L of pi, you get empty set. Empty set is also pi in another set theory. This pi, both are different. This is expression and this is a set. Even though we have the pi in different two topics, we call them as with the different names. Pi is expression as called as empty expression in the regular expressions. This pi is empty set in the set theory. Set theory is different topic, language is different topic, and expressions is different topic. But in both the places we have the two different names, right? This pi is called as empty expression, this pi is called as empty set. Okay, so understand the pi has many names, right? Depends on your usage, you are going to use the name. And epsilon is expression, A is expression, AB is expression. And if you ask what is the language generated by epsilon, I'll write here. L of pi is a pi, you can call it as a pi. L of epsilon is just having a set which has epsilon. A language represented by A will also generate one string A. L of AB, the language generated by AB is one string AB. Okay, and remember this, sir, both are look like same, but names are different. Here I am treating as expression, here I am treating as a set. Okay, in both the places this pi is used, and both are equivalent but both are not same. Okay, and everybody you can use in expression, and the set, the pi you can use in a set if you want it, correct? And of course you call it as empty set, and nobody is a set here. These three not called as a set. Everybody, they are strings but they are not sets. They are expressions but they are not sets. And this is a symbol but these two are not symbols. All are strings. Okay, all clear? This is how you understand the notations, and people are not aware of all these basics, but they solve a lot of difficult problems without understanding. But when some crucial concepts comes, important concept comes, they may fail to understand if you lost these basics. Here the thing is, like, they use the bar. Bar people may use for the set, bar people may use for the string. Are they same or different? Definitely different. Even though we use a bar used for the set is nothing but this bar is called as size. Size or length of a string is, suppose if I use AAB, then we call it as a 3. So this is called as length of the string, size of the set. So both names are different. Size of a set, this is length of a string. So same bars you can use to denote two different things. Okay. Also remember this point. Due to that, the people talk about what is the difference between these two. And here it is called as the empty set, which is 0. This is not empty set, this is a string. The string has no symbol, you will get a 0. But both are different. One you are talking about a set, other you are talking about a string. Okay, this is a string, this is not a string. Okay, this is called as length of epsilon, this is called as size of empty set. Size of empty set is 0 because no object in it, and length of the string, empty string, is 0 because that string has no symbol in it. Okay. I hope you have no problem with this. But this is empty set. Remember that? This is not empty set, this is empty string. Both are completely different. So you got the clarity? So all the basics are clear. Of course, we will talk about this soon. There are also regular expressions. And who are not regular expressions? I want to talk about that. Okay. In case if you have any doubt, quickly you can ask using this Telegram group. I'm just watching it. If anybody asks, only Aditya is there in the Telegram to discuss. Fine. Now, you can see what I'm going to write. Identify expressions, regular expressions. We call identify well-formed formulas, right? Regular expressions should be well-formed. Example, suppose I write A plus B. Second, A plus B. Are they well-formed or not? Just look at and let me know which is well-formed or which is not. In this, not all are regular expressions, right? Which are well-formed, they are only regular expressions here. Can you identify them? Waiting for your answers. So well-formed formulas are going to be those you can understand clearly. Operator is a binary operator, is applied for two operands. In which of them is applied properly? Is it applied well-formed? This is a well-formed? Yes. Well-formed, you are able to understand. This is one expression, so you can also close it as this plus is applied to both of them. This plus is applied to both of them. And here, without taking the right operand, the plus was closed, right? This is not well-formed. Even you see that the operator was closed without any operands. And you cannot use the regular expressions, and you cannot use the plus to write the regular expression like this. Able to understand? So similarly, you can also apply for concatenation. I'm not writing for concatenation. Just replace plus with the dot. You'll get the same similar answers. Correct? And I'm going to help you for clean star. Clean star, can I write like this? A star, perfect. Can I write like this? A star, that's also right. Ninth. Can I write something like this? A star, right? Which is the well-formed? This is well-formed, but this is not. You cannot close the operator without operands. Okay. I hope you have no issue with understanding the well-formed regular expressions. One of the exam they have mentioned like this, and ignore it because it is not a regular expression. Everybody, one of the GATE exam they asked like this: R star is equal to R star. Will it be equivalent? R star is well formed. This is not a well formed. It's not expression at all. First thing is getting. So this is not correct because it's not expression. This is the expression. How can you compare, right? So now we know there are 4 operators, and also we know how do you speak those operators. Like plus is initially R. R means, if I write R1 plus R2, we can say either R1 or R2. So let me also help you. Whenever you want to form a language, this R1 plus R2 is the expression, correct? And the language you can write as L of R1 union L of R2, or you can say a language represented by R1 plus R2. So these are the languages, this is the expression, correct? Even similarly, R1 dot R2, when you have it, you can say language represented by R1, you can do concatenate with language represented by R2, you can simply say language represented by R1 R2. These two are exactly same. And similarly, R star, if you want to denote, then language represented by R star is the proper way to denote, and this will include all the powers like R power 0, R power 1, R power 2, all of them will be covered here. This is similar to language represented by R power 0 or R power 1 plus R power 2 and R power 3 and so on. You can also do the union individually, like language represented by R power 0 union, language represented by R power 1 union, language represented by R power 2 union, and all of them. Okay, so we are going to practice all these 3 notations. R plus also you can use similar, but don't write R power 0 during the basis. Are we ready? Now we know what are the operators we have. Are we ready to understand these operators? Okay, let's see, we will understand. And many times while we are using these operators, we are not sure how to use them. Like example, a very simple thing I'm writing here. Can you tell me what are the answers that you can simplify? You simplify, write a better answer for them. Of course, right answer, but you can simplify too. Whenever you see these expressions, any R means any regular expression. Okay, R means any regular expression. What will be your answer? Can I conclude the pi plus pi is just pi only, because pi has no string, right? In mathematics you write like this: empty set union empty set. You will write empty set only now in maths. This in regular expression you will write another way: pi plus pi. Got it? And also in this simple regular expressions, never write this thing. Okay, pi means already a set, and don't try to denote these things, because we are using sigma is equal to a comma b. For that you will never get that pi inside the bracket. Okay, and epsilon plus epsilon is just epsilon. If you try to understand in mathematics, epsilon means you will get this set, union epsilon means you will get another set like this. Is this epsilon only? You are just doing the union of 2 languages. Right. And when you simplify, same, you will get same set union same set in mathematics. Here you will get R. So you can always assume in general R plus R. R is any expression in the world. R plus R is R. I can explain like A star plus A star. Can I write A star? Anything. I don't care what is that. AB whole plus is there. Same thing you are doing with again AB whole plus. R plus R. Is it R only? You can apply to any bigger expression, and if you are doing the plus of 2 regular expressions, you will get the same as one of the operand. Able to understand? So this is one of the important notation that you have. R plus R is equal to R. This is called as one of the property in mathematics idempotent. If you take the same expression, if you do again with one of the operator here, plus is called as idempotent. Okay. Any doubt? If you have any doubt, please use this Telegram group. You can scan it and you can ask the doubt immediately. I'm there in the Telegram too. Here I've used the 4 notations. Pi dot pi. Now I'm using the concatenation epsilon dot epsilon. Can I continue the number better? A dot A, and when you write R dot R, what is in general answer? This is 8, right? Go ahead and answer it. Concatenation. In a concatenation, what do? You take the strings before the dot and you take the strings after the dot and you put in a sequence. Here before dot you don't have anything. So if you don't have anything, you can't form a string, right? So you will get back to the pi only. And epsilon means 0 symbols. You have a something 0 symbols followed by 0 symbols. It's 0 symbols only. Just like that, you have epsilon here, dot, you have epsilon here. You take this string and concatenate with this string. So epsilon dot epsilon is epsilon, you get it. Okay. And A dot A, you will not get 1A. Remember this point? I have seen a lot of people, they do the mistake. We did not do the union. If you do the union, you will get A. It's a mathematical operator. But when you go for mathematics, if you apply concatenation, concatenation means both are must. You take A and concatenate with A, you will get A square, that is double A you will get. But this is not equal to single A. Remember this? This is not equal to single A. You will get single A when you have epsilon here and when you have A. In a regular expression, simply I can say epsilon dot A dot epsilon. There you will get A, because 0 symbols followed by A is A. Okay. Yes, you will get only A, or you can say A square, or simply we call double A only. You can't reduce it. And R dot R, we don't know whether it is R or not, but it is always R square. And here you see pi dot pi, you got a pi. Epsilon dot epsilon, epsilon. But it is not always like A dot A is not A. So one of the mistake that we may commit, because for this two, it looks like R dot R is R. That doesn't mean that always happens. Remember this, A dot A is A square, but it is not A. Right? So in general, you remember this point, R dot R is always R square, but may or may not be equal to R. That depends on what is R. Okay? It is possible to be equal to R in some cases like this. Okay? There are many other cases too. Now this dot operator cannot be idempotent because R dot R may or may not be equal to R. So this property fails for the concatenation. So this idempotent is going to be failed for concatenation. This is failed for the dot. Okay? Concatenation is not idempotent. I'll write some things. Just let me know what will you answer it. R plus pi. What is your answer? 10. R dot pi. What will be your answer? 11. R plus epsilon. What is your answer? R dot epsilon. What is your answer? When you are dealing with pi and epsilon, always careful to get the answer. The mistake that we may commit at one place, at this place. And initially the 3, once you understand, you will never do the mistake, but this always has a problem. 11th. Go ahead. R plus pi is always R. The reason is this pi acts as identity for the plus operator, identity expression or identity operand for plus. And this is going to be pi. Why pi? Because pi is a dominator. You can also call annihilator. Dominator for plus. There's a dominator expression. Whenever you do, sorry, it's not a plus, right? Concatenation. For the concatenation, whenever you see the pi as one of the operand, whole result is pi. Correct? What is the reason to be pi? Because R represents some set, right? Dot, the pi represents there is no string in it. And you take this one of the string and concatenate with this, but you don't have anything here. You don't get a result. Okay? R plus epsilon, it's not possible to simplify if you don't know R. R will decide what will be the result. If R is not having epsilon, you have to take this. If already having that epsilon inside the R to generate, then result can be R. So we don't answer it, it's just same. Okay? You cannot simplify it. That depends on R. R dot epsilon is definitely R because epsilon means 0 symbols and epsilon is going to act like identity. For whom? Dot. These properties are very, very important before writing regular expressions, before understanding any regular expression, and do not miss any of these properties. These properties are just, backbone of regular expression. Any doubt, please use this QR code to ask in the Telegram group. If you have any doubt during this, I hope you will answer it now without any mistakes. Okay, so I'm just mixing up to get confidence what you are doing. I'm asking the question here, is R1 plus R2 can I write as R2 plus R1? 19. Is R1 dot R2 is equal to R2 dot R1? These identities are true or false? Epsilon plus phi. What will be your answer? Check it. Can you simplify? Yes, answer you can get epsilon because pi can't generate anything. Pi can't generate anything. It's just epsilon. A plus pi, again pi cannot generate anything, just like A union empty set. What will you get? A only now. Right? That pi has no importance while doing the union. And while doing the concatenation, epsilon has no importance. And pi dot epsilon. So from pi you can't get even single string. The whole result, pi is the dominator for concatenation. Remember, in the concatenation, if you see the pi as one of the operand, whole result is pi. And A plus epsilon, this is what I said, R plus epsilon. Now can I write as A? No, right? Because A is not having epsilon. If already A is having epsilon, something like this, plus epsilon, then you may write A plus epsilon. If you have epsilon, then no need to write this. Correct? R plus epsilon, is it equal to R or not? That depends whether this R is having epsilon or not. If r is not having epsilon, just like this, a plus epsilon, now you can't write a, but something plus epsilon, you can write the same thing when this epsilon generated by this. To understand what I'm trying to say, r plus epsilon, is it r or not, that depends on what is there in r. Okay, I hope you got a clarity why we are not writing a, because a can't generate, because these two are different strings. After doing the union, you should have a two different strings. Now if you write equal to a, you will lose that epsilon. Okay, so you can't do it, but I can write epsilon plus a if I want it. The same, just like here, r1 plus 2 is equal to r2 plus r1. r1 plus r2, is it equal to r2 plus r1? Yes, it is always. And r1 dot r2, is it equal to r2 dot r1? Need not be. Sometimes equal, sometimes not equal. Okay, this identity, if anybody asks, is this identity, that what is that called as commutative? Is that commutative property holds for the plus operator? Yes, commutative holds, right? Plus satisfies commutative property, or commutative property holds for plus. But dot cannot satisfy, right? Commutative property not holds for commutative property, not holds, not satisfies. For whom? Concatenation. Remember that this commutative property don't apply for the concatenation, because it may or may not be equal. This is a true statement, this is a false statement. Yeah, thank you so much. Just we have covered basics. Still there is a lot to cover. In the next session, I'll be covering ∞*, ∞+, more about them. Then we will start writing regular expressions to understand. Okay? So see you tomorrow in the next session. In case if you are having any doubts, I'll just ask some questions as I did not ask, right? So can you do homework for yourself, and you can discuss in my Telegram group. If you're not accessing this Telegram group and you are trying to find the answers, you can put in the comment section, I'll verify. Otherwise, you can discuss here in Telegram group. Now, I did not explain the ∞ ∞+, but I will ask the answers for them. Suppose you have a star, but somebody did plus epsilon. Second, a plus epsilon whole star. And 3, a star plus a star. And 4, a star plus AA whole star. And try to understand each one. I'll explain in the next session too. A plus plus a plus a square. 10 questions I'll provide. Try to answer. A star union a plus. A star dot a star. A star dot a plus. 10. A star a plus dot a plus. Okay, just do all these 10 questions, and we'll meet in the next session. I'll discuss all these concepts again, but before that, handy and answer it, all of them. So much for joining today. See you tomorrow with more examples and more practice on regular expression. Thank you so much.